So somebody wanted to know about functional visual fields, and functional doesn't mean like having function. Functional visual field means that it's a non-organic visual field. So even though we call it functional vision disorder, it really means non-organic. And what non-organic means is it doesn't match what we know about the normal anatomy and physiology of the system, and therefore it can't possibly be an accurate representation of the real field. And so the most common visual field defect that we see that's functional is a 5-degree field or a 10-degree field where you only have a central island remaining, and that's all you can, it's like looking through a straw. However, in a normal field, because the arc subtended is the same, but the circumference of the circle is getting bigger as you move away from a target, the field should be a funnel. That is an expanding visual field as you test further and further away. However, in functional visual field defects, they persist in their 5-degree island or 10-degree island or whatever they're claiming at 1 meter and 2 meter testing, and this is a tunnel visual field. So a tunnel is non-organic. It is a functional visual field because it has to expand the further you are away. So funnel is organic and tunnel is non-organic. Tunnel is the functional visual field defect. Now there are other functional visual field defects, but this tunnel thing is the #1 thing that people complain about. We can also test them with saccades. So you're testing their saccade, look at my nose, look at my finger. If they really have a 5-degree field, they won't be able to look at the finger because they can't see. However, because lay people think that's an eye movement test, they'll just look straight to the finger. So testing the saccade in the peripheral field is sometimes another way we can prove that this 5-degree central island is actually non-organic and is functional visual field defect. The other functional visual field defect that you might encounter is a monocular hemianopic field where the person claims they only can see half of one eye. Now the other eye has to be normal to test this functional visual field defect. And what you're going to do is you're going to test the same field with both eyes open. So because the nasal field of the contralateral eye, if this field is normal, covers the temporal field of the fellow eye, if you have both eyes open, the field should be normal under binocular testing conditions. That's why we have to wear a patch when we're taking a Humphrey visual field. However, if the patient says, I still don't see half, well, that's non-physiologic. So when we have a monocular field defect, we can prove that it's functional by testing the field with both eyes open. And even though the hemianopic field is the prototype for this, it doesn't matter what field it is. So if the person says, oh, the top half is missing or the bottom half is missing, if we test both eyes open, this field defect here should go away. But what if it's still there? Well, this part of the field is covering that part. So we can tell that someone has a non-organic monocular field defect by just testing with both eyes open. That is an amazingly simple way to test these functional visual field defects. The hard ones are going to be if someone has a hemianopsia, because that field defect is overlapping with the missing segment in both eyes. So this won't work on that. Another hard one is when you have central scotoma. That's going to be a hard thing to disprove. Luckily, both the homonymous hemianopsia and the bitemporal hemianopsia, as well as the central scotoma, are very rare field defects to fake. So if someone has a bitemporal, a homonymous, or a central scotoma, the burden of proof is on you, because that's almost never a functional visual field defect. So the two most common functional visual field defects, the tunnel field rather than the funnel field, test at 1 meter and 2 meter. And the one eye field defect with a normal eye on the other side, you can test both eyes open to prove those are functional visual field defects.